pink line down there, what was that pink line called?
Apodome.
The apodome, right? That was that distance from the center to the outside of my shape. But when I draw that, I not only split the side in half, but I also split the angle. So my little angle up in here is now 30 degrees, and I can use a special right triangle, right? What do I have to know? I have to find my apodome, and I have to have the length of my side. And then we had two different ways of solving the problem, right? We could use the new formula that we introduced. What was our new formula? 1/2 capital P times A, right? It's got to be a capital P, and it's the perimeter of what? The entire shape times that apodome. Okay, so we could do that. Right here, we're already given one of the sides of my hexagon. So basically, I take my 7.5 and multiply that by 6, and then I got to find my apodome. So how do I find my apodome? What math would I do? Come on, concentrate. Look at the board. What apodome, or how do I find my apodome? What's the math I would do? We already did the 360 thing. We got a 60-degree angle. So again, if I'm going to do these problems right here, this is what I'm worried about right there. That little triangle towards the right-hand side. And I already figured out that this was 30, right? Because when I drew this apodome, I cut this angle in half, and we already found out that that was 60. So this side down here we can figure out because they gave us the length of the side, but what do I have to do to 7.5? Divided by 2, so what's that?
37.5.
What?
37.5. Cora? Oh no, I meant, never mind. I didn't, yeah.
3 point what?
Yeah, I didn't mean, sorry. Yeah, I told you, okay, I was.
Alright, so how do I find my apodome? Again, my apodome is this right here. What math can I do? I could do special right triangles, right? 1, 2, square root of 3. So am I going to multiply or divide? I'm going to multiply. So this right here is really 3.75 times the square root of 3. I'm just going to use that number. Yeah? So now I'm going to go back and figure out the perimeter. So I'm going to take 7.5 times what? Oh, times 6. So what do we get? 45?
Sure.
Come on, people. 5 times 6 is 30, carry to 3. 42 plus 3 is 45. So what do I do with 45? Okay, divide by 2. I could. What else do I have to do with it? So I'm going to multiply those two together and then divide my answer by 2. Agreed? This right here is my capital P. This is my little a. Alright? So I'm just going to punch that all in my calculator. Do not round until the very end. Do not round until the very end. So that's what we did on Friday. Apparently, when I said don't worry about math over the weekend, none of you really did. Because you haven't started worrying about math yet. Holy cow. Maybe we should just have a quiz today. Then maybe you guys would all care about something. So the next part on this is something called composite figures. So this is the rest of that section. Composite figures to me is just taking a weird shaped something or another and cutting it up into things that we would know. And then basically adding all of those things together to get the area of that weird shaped object that we had at the beginning. The only thing that you have to make sure of is that you can't overlap anything. So you don't want to do more than, or do something more than once. So what are we going to do? We're going to try to get the area of things that we know. The area of rectangles. Or maybe we should actually say parallelograms here. The area of a triangle. the area of a circle. These are all things that you should have had earlier on the last quiz, right? Maybe a trapezoid. Probably not, but it's kind of hard to make a trapezoid out of things. But what's the area of a parallelogram?
Base times height.
Base, little b times h this time, right? What's my triangle? 1/2 base times height, or base times height divided by 2. Area of a circle. Pi r squared. Kind of a trick question because a lot of people just throw out 2 pi r there. And my trapezoid?
1/2 base 1 base 2
Times height. So h times b1 plus b2 divided by 2. And then obviously we could still use our polygons. And honestly, we should write regular polygons, right? And that was what again? What did we just talk about? 1/2 PA or PA divided by 2, right? So those are all things that we're going to try to use to cut up our shapes and figure it out. Some of these problems are kind of fun. Okay? So if you want to see the postulate, the area of a region is the sum of the areas of all of the non-overlapping parts. So we're going to cut it up into, and when Kenzie looks at hers and compares it to Jazz's in study hall or something, you might have done it totally different, but you should always come up with the same answer. So if there's a way to split up the problem into little rectangles or parallelograms, you can split it out however you want. You just have to have one of those things that you turn it into. Yeah? That makes sense what I'm saying there? So, like I said, to me this is fun. So here we go. The dimensions of an irregularly shaped pool are shown. What is the area of the surface of the pool? So in a sense, we're just trying to find the area of the shapes. So what do you think? Are you good with how they split it up? Okay? The most important thing is the way that they split it up, can you figure out everything that you need? So in my rectangle is really a parallelogram. Do I have base times height? What are my base times height for my rectangle? 32 times 16. What's the base times height for my triangle? 32 and 15, and then I would do what? Divided by 2. And then how do I do the end pieces? 64 times 5. Because I can take those two end pieces, basically chop them off and stick them together, and that would make a true triangle, right? Or sorry, a true circle. What happens though if, let's just say that our pool didn't have the left-hand side? What would I do to find the right-hand side of that circle? I do the circle divided by 2, exactly right. Okay? So, you need to see the math to add all those things together? Everybody okay with what we're doing there? So that one wasn't too bad, right? Let's see if they got a trickier one. And of course, they basically do the same thing. Oh, that's a good one right here. So, find the area of the shaded region. So, can I do this? What the heck am I going to do if I want to find the area of the shaded region? Perfect. Can I find the area of the big rectangle? Do I know the length of the top of the blue thing? How much? 150? Everybody agree with that? What's basically my height of the blue piece? How much? 70. Because you did what? 25 plus 25 plus 25. Everybody agree with that? Okay. What is the base times height of the white region? 100 times what? 20? And then, as Bo said, I'm gonna subtract those two out. Okay? Make sense there? Everybody good with this? Okay? Now, when we did these problems the other day, I kind of told you that this was gonna be one of the harder sections that you have to do. And on Friday, people looked at me like I was dumb, that they thought it was easy. Okay? Now you gotta prove me that I'm dumb. I'm used to it. So, make sure you do the problems right now, you got a lot of time. Okay? But this does bother a lot of people to do these kind of problems. So make sure you are working on the problem.